بسم الله الرحمن الرحيم. هنكمل الطريقة الحديثة أو واحدة من الطرق الحديثة في عمل encryption، هي الاكسبوننشيشن سايفرز أو الطريقة الأسية. طبعا دي ظهرت سنة 1976، الطريقة بتاعت بوليج وهيلمان. طريقة كانت مبنية على الموديولار أريثمتيك، يعني مود specific prime number، بس طبعا prime number odd not 2، وبنعمل exponentiation للبلين تكست باور some key اسمه الاكسبوننت e. والشرط هو ان النتيجة تكون اصغر من البرايم نمبر b. Be careful here, we have two p's, the plain text capital B, the small p is represents a prime number. Here we use the same table as before for the numerical equivalence of the letters, but we use two-digit numerical equivalent. That's to say A is 00, H is 07. It will not matter if it is to the left, but if it is to the right, it will make a big change. Now P is an odd prime, E is the exponent, which is relatively prime to P minus 1. We know, we will see for the proof and the correctness of the transformation that this is very important part of the conditions to do such an exponentiation, to use the Fermat-Little theorem and its corollaries to prove that this transformation is invertible. This can be used as a monographic cipher to change letter by letter, and a digraphic cipher or polygraphic cipher as follows. We check for the first if it is monographic. The Z is represented by A is 00, B is 01, and so on till the last letter is 25. The thing is, if we change letter by letter, we need a prime number which is bigger than 25. So Z is 25, therefore the smallest p possible prime to use in exponential cipher monographically is what? We mentioned this in the lecture. P will be some prime number bigger than 25, which is 27 is not prime, 29 is the prime I mean, and so on. If we take this for monographic, for digraphic exponential cipher, this to mean we change two letters by two letters. So the maximum we can get is Z. This represents the 25 times 25. So we are looking for the prime P bigger than 2525 is needed. So a prime like this is needed. For example, the one here is in the example 1 is P equals 2632. Yes, this satisfies the condition, and this could be used as example 1. In example 7.1 in the reference, give you some question to think about. We think about it together. In exercise 1, using the prime number P equals 101, this is the 26th prime number. This is the prime number 26 in the list of primes because there are 25 primes less than 100. This is the first prime number after 100. This is number 26 in the list. Is this okay to do digraphic? No, this is less than 2525, which is needed for digraphic exponential cipher. So using this, we can only do monographic cipher. This to change letter by letter. But we have something new here in the monographic cipher. It is not one-to-one correspondence between the 26 letters and the 26 letters again. No, we change the 26 letters into the numbers from 0 up to 100. So we can get number 99, 98, 97, whatever. So it is not letters to letters, but letters to number. So the area is very wide here in this way. The condition on E, the condition on the exponent to which we raise our plain text is to be relatively prime with p minus 1. Of course, p is odd prime, so p minus 1 is even, and this condition to be written like this: GCD of E, and p minus 1 should be 1. This is the relatively prime or coprime condition of the exponent with p minus 1. This is necessary for the proof, as I mentioned before, and you are asked to do the proof. We've done it in the lecture, and this is very important part of the mathematical cryptography aimed in this course. Try to make a sketch of the proof after a while, but let's do some computation first with the enciphering, the first direction of enciphering using the exponential cipher. With I'm looking for easy calculations. Let us go with exercise 1. Use p equals 101 and enciphering key the exponent e equals 3. I usually ask you about checking and verifying the conditions of the transformation and the inverse transformation. So does P satisfy the exponentiation cipher conditions, and E, does it satisfy the exponent cipher condition or the enciphering key condition? We will see. Encipher the message. Good morning. Using modular arithmetic, modular exponentiation, الأسس. So the question here is, what is the length of the block we use? Is it monographic cipher or digraphic cipher? Okay. P is 101, and 1, which is less than this, ZZ, with the 2-digit equivalence. So this we cannot do digraphic cipher by this number. So P 101 is less than 2525, therefore, and this is bigger than 25, so this P enables us to do monographic cipher. monographic cipher or exponential cipher. That's to say letter by letter. So we go for the first block. In fact, it's not a block, it's only one letter, first letter will be the G, this one, and this is equivalent to, what is the G in our table? Is 6, or here 06, or simply 6 because it's in the left. So now we're using, be careful if P is some prime number less than 29, which is 23 or 19 or whatever, less than 29, this will not be allowed in this method. Mathematically speaking, this will be a function which has no inverse or may confuse us with many sorts of ambiguities. So let us do the part 2 of the problem. The exponential cipher relation is CP, capital B is the plain text to the power of E mod the prime number P. Look, the difference between the capital B, the plain text, and the small b, which is the little b, is the prime number. So put P equals, the plain text is G, so P stands for plain text, which is G in this case, or 6 in this case. So C is 6 to the E. What is E? E is 3. Oh, we didn't check the condition for E. The condition for E, let's do it here. E and P minus 1. So it's a 3 and 100, which clearly gives a highest common factor 1. Therefore, this is satisfied. So the two conditions are satisfied for monographic exponential cipher. So this is mod P, mod 101. This is easy. 6 cube is known to be some mental arithmetic. It's known to be 36 times 6, which is 216. Let's check. 6 to the power of 3 is, so something went wrong. 6 to the 3 is 216, mod 101. 216 divided by 101 equals, so it's 2 and something, so we change the division by subtraction to make it multiplication. So it's 40, mod 101. So the letter G, therefore G is enciphered to 14. And go for the other letters one by one. Do the rest one by one. This, I leave this as an exercise, DIY as usual. So you need to be careful and check all the conditions of the relations in every method we study. We are interested in the mathematical relations and the inverse relations and verifying the correctness of the relations used, and applying this in number theoretic terms and do it in details using the pocket calculator. So we won't deal with big numbers but small numbers, مع ان طبعا دوت مش الحالة الحقيقية لكن هو ده المتاح في نوع امتحاننا. So let's go back to the smallest The smallest number if we use blocks of 2 letters will be 2525 because Z is represented by the equivalent 2-digit number 25. So as in example 1, P is, so we go for example 7.1. We are given P equal to 633 and E equals 29. Don't mix this 29 with the 29 we were talking about from a few minutes. There it was the prime number. Here it is the exponent itself. So check the condition. The condition of the exponential cipher. Is this allowed for this? Check the conditions for digraphic exponential cipher. The question means, is this a correct prime number which enables us to do digraphic, means blocks of 2 letters, block, or in equivalence 25 equivalent number, and whether E is relatively prime to the P minus 1. So condition 1, is P a prime number? Is P equal to 633 a prime? How to know? If we have the table of the first few primes or 500 primes, we will see this. And if we have the calculator which makes the factor operation like this, we can check 26633. We write it, enter, and then check the factoring. So it is written again as it is, so it has no other prime factor. So it is itself a prime number. Yes, it is. And P is bigger than 2525. So it's okay. It's valid. Prime for digraphic exponential cipher. Part 2 of the conditions here, the GCD of E and P minus 1. So it is GCD of 29, and P minus 1 is, subtract 1 from this, the preceding number, 2632. So it's can be done easily by such a calculator because we can factor this. This itself is a prime number. 29 is the 10th prime number. This is known, but this is not a prime, it's an even number. So we can factor it using this calculator. So it is 2632. We can factor it like this. Okay, we have 2 repeated 3 times, 747. So it is 29 and 2 times power 3, 7 once, 47 once. This clearly we have no common prime factor, so the greatest common divisor is 1. Therefore E is allowed as well, allowed exponent. We go back to, this is part of our type of questions in mathematical cryptography, to prove or disprove statements, to verify the mathematical conditions, to prove the correctness of the inverse functions as usual. So go to the example. Yes, he does the confirmation as well, the verification, the checking, but very fast. We do it in details, and you should have this habit of checking and verifying your work step by step, letter by letter, to encipher the okay. Asking you to encipher the plain text. This is an example of part 3, encipher. The plain text. Question, we read it again. Let the enciphering key used in the exponent in the modular exponentiation. So you find the name of this method, don't mix with the previous ones and the coming ones. So you need to check which type of ciphering and deciphering used. You are asked to use exponent in the modular exponentiation. The message is encipher. This is an example of so and so. So here we first convert the letters into the message. We take the 2 letters first. So first block is TH and the T is 19 and the H is 07. So we are in a position to transform the block, the first block for 2 letters to TH with this 4-digit number 1907 into its D. This will represent the plain text, and we are asked to find the cipher text. This is the plain text, and this is the cipher text. The rule is to be written in symbols, the capital B to the E mod little p. This is the exponentiation relation, exponentiation cipher formula, mod p, which is 2633, which we verified that it's a prime number bigger than 2525. So plain text is 1907 to the power of E. E here is 29 mod, what's P? P is 2633, the prime number in this modular exponentiation. Now we need the procedure which make this huge exponentiation mod a big number very fast, which is squaring technique or recursive squaring. The successive squaring we need طريقة التربيع المتتالي. We mentioned in the lecture and دكتور محمد إن شاء الله يعمل فيديو مخصوص عن هذه الطريقة. أنا هعملها بطريقة بسيطة بدائية، وبعدين نشوف الفيديو التاني عشان نتعلم الألجوريثم ده من أهم الألجوريثمات في المودرن كريبتوغرافي. أوكي، تربيع متتالي or successive squaring method. نقدر نعمل طبعا بدل ما نضرب 1907 في نفسها وبعدين في نفسها وبعدين في نفسها 29 خطوة، نقدر نوصل بسرعة جدا باور 2 وبعدين نضرب باور 2 في باور 2 يديني باور 4، باور 4 تايمز باور 4 نوصل لباور 8، باور 8 تايمز باور 8 نوصل لباور 16، باور 16 تايمز باور 16 نوصل لباور 32. ودون نيد، مش محتاجين باور 32، فهنقف عند باور 16. طب والباقي ننقي من اللي عملناه اللي يجمع لي 29. دي الطريقة البدائية للتربيع المتتالي. تعالوا نعملها. طبعا في طرق أحسن وأسرع من كده، ولكن تعالوا نعملها بطريقة بسيطة زي ما احنا بنقول هنا. فتعالوا نعمل الشغل ده. 1907 power 1 is 1907. طبعا الميزة هنا في الموديولار اريثمتيك ان احنا عمرنا ما الاعداد هتكبر، حتى لو باور 1000 10000 مليون مليار، اعداد اكبر من كده بكتير حتى باور 1000. طالما في موديولار اريثمتيك فاحنا كل ما العدد يكبر عن الموديولس بتاعنا هننقصه تاني ونبسطه ويكون اصغر من الهايلايتد موديولس اللي we dealing with في البروبلم بتاعي. 1907 باور 2 equals، هنا هنعمل الشغل ده بالآلة 1907 سكوير، فده هيطلع 3 6 طبعا ده أكبر من الموديلس بتاعنا، فتعالوا نعمله. نقسم 3 طبعا لو في آلة تانية يبقى أحسن. نقسم دوت على الموديلس بتاعي 2 6 هيديني الناتج ده 1381 وفراكشن أو ريمايندر. فهنحول العملية دي، ندخل كده نحول القسمة دي لطرح ونحولها طرح 1381 تايمز ده هيديني الريمايندر اللي أنا عايزه. فالأرقام بتتبسط أولا بأول. 476 مود بي. مش عايز أكتب الرقم الكبير ده تاني. دلوقتي بعد ما وصلنا باور 2 مش هضرب في 1907 عشان اجيب باور 3. مش محتاج باور 3، محتاج باور 4. او كده احنا بنسرع العملية. باور 4 means هنعمل سكويرنج للعدد ده 476 سكوير، ولو العدد عدى البي نبسط تاني بنفس الطريقة. فتعالوا نعمل التكنيك دوت سهل جدا. 476 سكوير equals ننقل 226576 مود بي 226576 نعمله تاني 22656 نقسمه على الموديلس بتاعي اللي هو 2633 هيديني 86 وفراكشن او ريمايندر. احنا interested in this integer quotient minus 86 minus 86 times we'll get a number which is 138 mod B. طبعا الارقام الحقيقيه والحسابات الحقيقيه بتبقى اكبر من كده بكتير وبتتعمل ببرنامج بالكمبيوتر يعني، لكن احنا بنتدرب على الماثيماتيكال كريبتوجرافي اللي احنا الخطوات الاولى والبروفس بتاعتها والعمل بالبوكيت كالكوليتر بس. تعالوا الخطوه الثانيه بالسكسيسيف سكويرنج. بدل ما هعمل اضرب في 1907 عشان اوصل لباور 5، لا احنا هنعمل باور 8 فورا. So successive squaring means this: squaring again. امتى نوقف؟ لما نكون هنعدي الباور required power is 29 so we don't go to 32. نقف عند 16 ونشوف هنعملها ازاي. فدوت يساوي 138 square which is 138 squared is 19044 mod B 1904 طبعا اكبر من الموديلس بتاعي فنبسط. وديت الفكره العبقريه في استخدام الموديولار اريثمتيك، ان احنا عمرنا ما هتكبر الاعداد، دايما هنكون less than الموديلس اللي احنا بنشتغل بيه في حساب الساعه. divide by 2633 هيديني 7 وريميندر. احنا عايزين الريميندر من الديفيجن دي فنعمل ماينس 7 تايمز ده. سوري minus 7 times ده يديني 613. نتأكد تاني. 19,044 divided by 22,633 is 7, yes. So we change the division sign into minus sign and multiply the 7 by the divisor. So delete minus 7 times, which is 613, that's right, yes. We square again. Okay, this is power 16 will be the square of this result, 613 square. 613 square will give you this, 375769. Mod B. Simplify. Mod B means 375769 divided by our modulus to 633 to get 142. We don't look at this fractional part at all. We take the integer part of the divisor and look for the remainder of this division. So we go change it into minus sign 142 times the divisor to get the remainder, which is 1883. Mod B. The next squaring will go to 32. We don't need 32, we need only 29. Now we are looking for 1907 power 29. We can gather the power 29 from this information. 1, 2, 3, 4 steps. We reach the power 29 in 4 steps of squares or squarings. And we can collect this from the binary representation of 29, which will be explained in details in another video by Dr. Muhammad, inshallah. So we put the 29 as a sum of powers of 2, like this. 1907 power 16 plus 8. This is 24. 24 plus 4, 28 plus 1. 5 plus 8, 13 plus 16 is 29. That's to say, we multiply this 1883 times 8. This one 613 times power 4, which is 138 times power 1, which is 1907. So the problem of successive squarings simplified our computation to this few steps. Even if it's 32, we will need one more step. Even if it's 100, we need one more step to go to 64. And then collect the suitable sums to get the required exponent. Now we multiply this and simplify, multiply this mod P and simplify, and multiply the result and simplify. Let's do it again, complete our work in details. Be sure you do this yourself, and you will do it in the final exam, inshallah. So 1907 power 29 is congruent to, so let's do this. 1883 times 613 is this big number, 1154279, 1154279, 1154279. Divide this by our modulus is 2633 to get the result is 438. So we change this division into subtraction to get the remainder. Delete minus 438 times to get this product mod P 1025 times this one. 138 times 1907 equals this big number 263,166. Copy it again. 166 divided by our modulus 2633, which gives 99 as an integer part of the quotient. So we change this into minus 99 times this will give you the remainder 2499. So this is 1025 times 2499. Remind yourself that we are working with mod B. This is congruent to 1025 times 2499, which is 256,1475, which is congruent to, copy it again, 256,1475 divided by your modulus 2633. 256,1475 divided by gives this. The result is 972, the integer part of the quotient. So change this minus 972 times this will give you this 2199 mod P. This is, as you see, our computations are correct, as you see here from the revised version we have here. The first block 1907 is transformed into the ciphertext 2199. So the first block of 2 letters, this TH I mean, is in 2-digit equivalents. Now 1907, we exponentiate this plain text to the power of, to the exponent of 29. The key here is power 29, mod P, the given prime number. We get to this, and you do the rest. Of course, in the exam we do something like this, but not all of these blocks. I urge you to try it yourself and DIY. Check some of the other blocks in this example 7.1, and we'll continue after the break.